we're going to do another example of the area between polar curves for BC calculus. So let S be this blue shaded region in quadrant 1 that is bounded by r equals 1, which is just a circle of radius 1, and r equals 2 sine 2 theta. So r equals 1, right? R equals 1 is this circle of radius 1 centered at the pole or the origin, right? So that's definitely my inside curve in this situation. And r equals 2 sine 2 theta is this rose curve that has this petal that peeks out past the circle. That's the area we want to find. So that's definitely my outside curve. So first I'm going to write an integral expression for the area of S, and then I'm going to use a calculator to find the actual value of that area. So first thing we have to do is we have to find the bounds. We have to find when the blue curve intersects with the red curve. So the first thing I need to do in part A is I need to find the bounds. I need to find when r equals the other r. So when does 1 equal 2 sine of 2 theta? Well, that's when 1/2 is the sine of 2 theta. So that's when 1/2 is the y on the unit circle. Because of this 2 inside the angle, I'm going to have to go and answer more than just the interval I'm looking at. Now, I want only points in quadrant 1, and there's only one y value in quadrant 1 that has a value of 1/2. But the problem with that is that because of that 2, I need to go twice as far. So I want both the pi over 6, and I want the one in quadrant 2 that is a 5 pi over 6. The reason I want both of them is what's going to happen is that my angle is not a theta, it's a 2 theta. So 2 theta is going to be pi over 6, or 5 pi over 6. When I divide by 2, I get that my thetas are pi over 12, or 5 pi over 12, and 5 pi over 12 does fall in quadrant 1. You can tell that because right here, that's pi over 2, which would be 6 pi over 12. So 5 pi over 12 is still in quadrant 1, right? So again, those are my two bounds. Once I know my bounds and I've identified my outer curve and my inner curve, then my answer for part A is simply a matter of 1/2 the integral from pi over 12 to 5 pi over 12 of my big R, which is in this case the 2 sine of 2 theta whole quantity squared, minus my little r, which is just a 1 squared with respect to theta. I would not clean this up at all. If you clean it up, you run the risk of making a simple mistake, right? When I go to do part B, which again on a real AP would not be a standalone part, on a real AP you would either be asked to do just what I did in part A, or you'd be asked to go the whole way through and do what I do in B. So I'm going to go ahead and put I put them in the order that they're given to me. That's always the safe way for me to remember which one's which. So I put r equals 1 as my r1, and I put r equals 2 sine 2 theta as my r2. Double check that in mode you are in radians and polar. Obviously, I was in r's, so it must be polar. When I quit out of here, I'm going to go ahead and use 0.5, math 9, which is function integrate. I'm going to do my big R, my outer R, so r2 quantity squared, minus r1 quantity squared, comma, with respect to theta, from pi over 12 to 5 pi over 12, and I hit enter and get a 0.956 or 0.957. So my answer to part B is that this is approximately a 0.956 or 7, depending if you round or truncate. And that is our second example.